Imagine a sound no human could ever hear, born in the crushing gravity where not even light escapes. Scientists claim they've captured whispers from the most forbidden place in the universe. But how do you hear a black hole when it's literally silent to everything we know? In 2025, a signal emerged from the LIGO detectors that met theoretical predictions. Hidden within the roar of a black hole merger was a whisper from the edge of the event horizon, the line where physics itself begins to unravel. This direct wave carried echoes from a place no telescope has ever seen, the edge of the event horizon. It was a pattern so faint it required stripping away every known signal to surface, like finding a heartbeat buried in thunder. The wave didn't just tell us about the collision, it mapped the warping of spacetime as it collapsed into the unknown. For the first time, we might be hearing the shape of gravity itself, bending around a point of no return. But that wasn't the strangest part. The signal's rhythm matched predictions so precisely, it felt like eavesdropping on Einstein's equations in their final moments. The team had to subtract the entire merger's aftermath to isolate this ghostly imprint. What was left was too perfect to be noise. It's as if spacetime sent a postcard from the edge, written in ripples only our most sensitive instruments could decode. This is the closest we've ever come to touching a black hole's boundary without crossing it. Yet the direct wave doesn't reveal what lies beyond. It only confirms the edges, listening. The implications are staggering, a new way to probe regions where light dies and time folds. But what exactly is listening to us? If we can hear the edge, what does that mean for the darkness beyond it? The answer may lie in the next signal they isolate, assuming the universe is ready to answer back. For now, this whisper is both a map and a warning. We've reached the limit of where physics can walk beside us. And the horizon is still speaking. If this kind of wonder keeps you up at night, you're in the right place. Subscribe so you don't miss what comes next. In the aftermath of GW 50114, the gravitational wave carried a ringtone pattern no one expected. It echoed theoretical predictions about physics at the event horizon, physics that had never been tested. The researchers stripped away the familiar hum of post-merger vibrations. What remained was a secondary signal, decaying at rates that defied every model they'd built. This wasn't just spacetime settling into silence. It was a rhythm, precise and persistent, like a heartbeat fading into the void. The pattern suggested the fabric of space itself was vibrating, as if plucked by an invisible hand. But these vibrations occurred at scales where quantum gravity might finally leave a trace. A scale so small, so extreme, that our equations struggle to describe it. Some called it a whisper of the quantum realm, hidden beneath the roar of cosmic violence. But that wasn't the strangest part. The decay rates hinted at something older than our theories, something that might rewrite them. Gravitational echoes, the idea had long been a fringe hypothesis. It proposed that event horizons aren't smooth, as Einstein's equations demanded. Instead, they might shimmer with distortions, like ripples on a pond. Each echo would carry a fragment of what happened at the edge of a black hole. A region we cannot see, but may soon hear. The signal from GW 50114 matched this idea too well to ignore. Yet the data revealed something even more unsettling. The spacetime around the new black hole didn't relax symmetrically. One side settled faster than the other, as if the universe itself was out of balance. This asymmetry challenges the very notion of how black holes stabilize. For decades, we assumed they smoothed into perfect, featureless spheres. But this signal suggests the process is chaotic, jagged, and unfinished. The decay pattern contained a second twist, buried in the noise. The signal didn't just fade, it fractured, repeating at intervals too regular to be random. A cosmic feedback loop, amplifying the edge of reality before it collapsed. If confirmed, this would be more than a new tool for observation. It would be evidence of a mechanism we've never measured, one that bridges gravity and quantum mechanics. The implications stretch beyond the horizon. This signal could test the information paradox, the firewall hypothesis, the fate of matter that vanishes into darkness, without ever peering inside a black hole. But here's the catch. The pattern only makes sense if spacetime is more fragile than we believed. If the event horizon isn't a boundary, but a surface, something that can bend, warp, and perhaps reflect. The researchers called it a direct wave, but direct to what? A deeper structure, a hidden layer of reality. The data doesn't answer that question. It only confirms that the answers lie closer to the edge than we dared to search. And the edge is not what we thought it was. The universe has been whispering all along. We just needed a collision powerful enough to amplify the sound. A collision like GW 250114, violent, precise, and incomplete. The final mystery lingers in the signal's repetition. Why does spacetime vibrate in this particular rhythm? Is it a fingerprint of quantum gravity, a message from beyond the horizon? Or something else entirely, something we haven't yet learned to ask? For now, the signal is both a key and a riddle. It opens a door to the unknown, but locks it behind questions we can't yet answer. This signal isn't just a cosmic hiccup, it's a dialect in the universe's oldest language. The direct wave acts like a mirror, reflecting the warping of spacetime where light itself is silenced. What if these whispers carry secrets about gravity's final dance with quantum mechanics? For the first time, we might eavesdrop on the moment infinity folds into itself. Future mergers could map the event horizon in exquisite detail, pixel by pixel, ripple by ripple. Einstein's equations have guided us here, but they may not hold the full truth. Theorists whisper, could these waves reveal if singularities are real or just mathematical ghosts? Each new detection tightens the net around the unknown, pulling answers from the void. Imagine a map of the horizon, not in light, but in the tremors of spacetime itself. The direct wave doesn't just show us the edge, it hands us a ladder to climb it. But what waits beyond? The answer may rewrite our understanding of reality. Some suspect quantum gravity's fingerprints are already in the data, hiding in plain sight. As observatories sharpen their ears, the universe grows quieter and more insistent. The horizon isn't a wall, it's a conversation we've only now learned to hear. What if Einstein's vision was a prologue, not the final chapter? The true test lies in the next collision, the next whisper that might shatter our models. We stand at the threshold of a new era, where black holes teach us to listen. The final secret, it may not be about the holes, but the fabric they tear and mend. And somewhere in that fabric, the universe is waiting to be understood. If black holes sing in gravitational waves, what song are they trying to tell us? If this journey stirred something in you, leave a like. It helps whispers of the universe reach more curious minds. And hit that notification bell so the next wonder finds you first.